Hello, good day viewers. In this tutorial, I would like to derive that formula used to find the area under the curve using sigma notation. So this is just what? Definite integral from definition. Another version of what? Riemann sum. So suppose we have a function or a graph of a function f of x like this. Suppose we have a graph like this. For example, this is a graph of f of x. And it happens that we want to find the area between A down to B. We are going to use right Riemann sum. So to do that, you have to inscribe as many rectangles as possible here of equal bases. Find the area of each individual rectangle, then add them all together to find the area under the curve, which is just what? Roughly approximated area. But I told you in our previous lesson that the more rectangles you inscribe here, maybe as this number of rectangles approaches infinity, you may likely get that accurate answer or actual area. Okay, so let's do that. I'm going to inscribe like 4 rectangles here. We may have one here. We may have another one here. Now we have 4 rectangles. I'm going to use these 4 rectangles to illustrate. You know that to find that area A, you have to take the base, which we call dx, then multiply by f of x1, that is the height of the first rectangle, plus the height of the second rectangle. You keep on adding after the last one, which is f of xn. And how can you find that? For example, this particular rectangle, if you want to find its height, you have to take the value of x here, plug it into the function. It will give you the corresponding value of y here, which is f of x. But this time around, it is going to be what? F of x1. All right. We know that the distance from here to here is dx. This is another dx. All of these bases are equal. So if you want to find the height of this rectangle, the moment you add dx to a, it will take you to this position, this particular position. Then add another dx, which is the base, it will take you to this one. So keep on adding dx, it will take you to the subsequent height. Okay, the first one here, the height of this first rectangle is going to be what? F of a plus dx. Then if you add another dx, it will take you this. So we have how many dx? 2 dx's. It will give you the height of this. So it will be f of a plus 2 dx. This is the height of the second one. The height of the third one, it will be what? F of a plus 3 dx. If you keep on moving, you are going to get f of a plus n dx. That will be the last one because we don't know the number of rectangles we are inscribing. So from here we can replace this 1, 2, 3, 4, 5 with k, for which k is equal to 1, 2, 3 to n, right? We can do that. So, but before then, let me substitute them here. We have dx times the first height will be this one, f of a plus dx. I'm not going to write all of them. You keep on adding up to the last one, which is f of a plus n dx. So from here we can take the summation of this, because we have seen that all these are sum of their respective heights, 1, 2, 3 to n. So we can replace it with a summation, which is going to be summation. We can use k, right? K from 1 down to n. It depends on the number of rectangles we are inscribing. Of what? Let me start with this one before this, because dx is just multiplying the whole summation. So the summation of what? F of a plus k dx. If you use I, you replace this with I. It's just a variable. Then multiply by what? That dx outside, waiting to multiply. Can you see that? As simple as that. So let me wipe this one and continue simplifying this, because we know what is what? Dx. Dx is defined as what? The upper limit minus the lower limit divide by the number of rectangles. Look at it. Upper limit, divide by the lower, minus the lower limit, then divide by the number of rectangles you want to inscribe, which we call n because we don't know their number. So we have the summation of f of a plus k times dx, but let me find that dx is what? What should I write it here? Remember that dx is equal to b minus a divided by n. So that's what I want to replace dx with. So we have b minus a divided by n. Remember, we still have another dx outside, which is still b minus a divided by n. So, but wait, if you want to get more accurate results, you have to take the limit as n approaches infinity, right? So we're going to do that here. So this is our area, remember? So our area would be the limit as n approaches infinity because we want to inscribe as many rectangles as possible of the summation. Okay, I have forgotten to write the limit here from 1 down to n of what? K equal to 1 down to n of f of a plus the whole of this. And I can call this one, if I like, I can replace the whole of this with f of xk. I can do that. Let me do that. But I know what k is. Or let me use I. F of xi times dx. I know this is dx, so I can replace it with this one, for which I know that this xi is equal to a plus k dx. You know, this is dx, this is k. If you multiply them, you have k dx. So this is the formula we're going to apply subsequently in finding the area under the curve. Simple as that. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.